Hello and welcome back to the channel. In this video, we're going to be learning about the bubble sort in Java. But first, we need to understand what sorting exactly means. So, in arrays, sorting is basically when you arrange the array or the elements of the array in a particular order. Usually, we're going to do this in an ascending or a descending order. But there are multiple ways we could do this. In Java or in most other programming languages, what we do is we use for loops to iterate the array and sort the array in a very efficient way. One of those ways is what's called a bubble sort. The bubble sort is incredibly simple, but it's not as efficient as some other sorting algorithms. Even then, it's really important to know. And an important thing you should know is that when you write a bubble sort, you have to use a nested for loop. So it isn't as simple as some of the other programs you've seen, like the sum of the elements or the least value or the maximum value. So let's just first look at an example of an array and see how a bubble sort would work. After that, we're gonna type the program and we're gonna test if it actually works. Right, so I made this array which has 5 elements: 22, 9, 8, 1 and 3. I'm using I as an iterator to iterate the array, and I made another variable called temp which is initially set to 0. You'll understand later why I made this variable. And beside the variable, I have a condition which is checking if a of I is greater than a of I plus 1. Now all this is saying is that it's just checking if the current value is greater than the next value or the next element in your array. And this is something that we're going to use to solve this array. An important thing you need to know is that this condition will change depending on how you're trying to sort your array. In this case, it's intended to sort this array in an ascending order. Right, so let's just start iterating this array. Now our I value is initially set to 0. So the condition is basically checking if a of 0 is greater than a of 1. In a bubble sort, you would take two elements. You would check if the first element is greater than the second element. If that's true, we're going to swap them. Now you notice that by swapping these elements, we're making sure that the order is from the lowest to the highest. In this case, we want to arrange our elements in the ascending order. Since 22 is greater than 9, we're going to swap these two elements. Basically, the value at a of 0 is going to become 9 and the value at a of 1 is going to become 22. And this is where we would use the temp variable. Now, you might wonder, why exactly do we need the temp variable? So, in this case, if I want to swap 22 and 9, let's say I copy the value of 9 into a of 0, I would get something that looks like this. But you notice then I would lose the value 22. Usually, and really in all cases, you wouldn't know the values of these elements. So I'll need some other variable that can temporarily store the value of a of 0 so that I can swap them. And this is where I would use the temp variable. So what we do is I could copy the value of 22 in my temp variable, and once I set a of 0 to 9, I can set a of 1 to temp, basically to 22. And that's really the main function of the temp variable. We usually use the temp variable just to swap the values. Now, I haven't sorted my whole array, but it's a step in progress. What we've done is we've sorted two elements, and as we keep sorting these elements in the same way, eventually we will sort our whole array. This is how the bubble sort works. Right, so if we proceed with the iteration, our I is going to increment to 1. And now we're going to be checking if a of 1 is greater than a of 2. Basically, if 22 is greater than 8. And we repeat the same process. We copy the value at a of 1, which is 22, into temp. We set a of 1 to a of 2. So we copy the value of 8. And then we set the value at a of 2 to temp, basically to 22. I've swapped them. Remember, the only reason I swapped them is because the condition was true. 22 is greater than 8. So I've swapped two more elements in the right order, in the lowest to highest order. Now our I is going to increment again to 2. Now we'll be comparing 22 and 1. We'll be checking if a of 2 is greater than a of 3. Basically, if 22 is greater than 1. This is true, so we're going to repeat the same process. We're going to swap them. We're going to set temp to 22. We're going to set a of 2 to 1. and we're gonna set A of 3 to 22. Once we've done with this, we've set two more elements in the correct order. And now our I is gonna increment again to 3. So we're basically checking if A of 3 is greater than A of 4. In other words, if 22 is greater than 3. This condition is also true. So what we'll be doing is we're going to swap the two values. And we're going to repeat the same process. We're going to copy the value at A of 3 to a temp variable. We're going to set A of 3 to 3. And we're going to copy the value in our temp variable, which is 22, to A of 4. Now, usually, you make sure that your iteration ends where I reaches the last index of your array. But in this case, that wouldn't work because it would cause many errors and many other issues. Let's say the value of I increments to 4. We'll be checking if A of 4 is greater than A of 5. Everything's fine, but you notice that our array doesn't have an index 5. I'm comparing A of 4 with an element that does not exist. And this will cause an exception or an error known as an array index out of bounds exception. Because the element I'm trying to access does not exist. So you have to make sure that the value of I doesn't end at the last index. It should ideally end at the index before that. In this case, 3. Now you notice that our array hasn't been sorted yet. But the largest value has been moved to the end of the array. What we notice is that as we keep repeating this process and as the larger values move to the end, eventually we will find that our array is sorted. So what we're going to do is we're going to repeat this whole process one more time. And in an actual program to do this, you're going to use a nested for loop. So our I is going to become 0 again. And now we're going to check if A of 0, which is 9, is greater than A of 1, which is 8. Since the condition is true, we're just going to swap them the usual way. So now that I've swapped them, our I is going to increment to 1. Now we'll check if 9 is greater than 1. This is true, so we're going to swap them. Our I is going to increment to 2. We'll check if 9 is greater than 3. This is also true, so we're going to swap them. And then we reach the last two elements. We're going to check if 9 is greater than 22. Since the condition over here is false, we're not going to swap anything. And we'll repeat this process another time. Our I will start again at 0. We'll be checking if A of 0 is greater than A of 1. If 8 is greater than 1. And this is true. So we're going to set temp to 8 and we're going to swap the two elements. Our I is going to increase to 1. We'll be checking if 8 is greater than 3. This is true. So we're going to swap them again. Our I will increment again to 2 and we'll be checking if 8 is greater than 9. This is false. So we're not going to swap the values. Our I will increment again to 3 and we'll be checking the same thing for 9 and 22. This is again false, so we're not going to swap or anything. Right, so we sorted our array. Now, in this case, it was actually quite simple. We didn't need too many iterations. We had only 3 iterations to completely sort our array. But in other cases, depending on the elements, we would need to iterate this multiple times to completely sort our array. Since we want to make a program that will work for different arrays, irrespective of the elements of the arrays, what we're going to do is we're going to make sure that this one process of sorting it is going to be done as many times as the length of the array. That's the maximum number of times you need to repeat the process to make sure that the array is completely sorted. In this case, we did it only 3 times and we found that our array has been sorted. But in some cases, you would have to do it more times to completely sort your array. That's just something to keep in mind. Now, let's look at the actual program to sort an array using a bubble sort. Right, to simplify this, I wrote 4 simple steps. And this is really all there is to a bubble sort. The first thing we're going to do is check if the current value is greater than the next value. That was our condition that we saw before. If this condition is true, we're going to swap the 2 elements. We're going to keep doing this for consecutive elements till the end of the array. And these first 3 steps are going to be repeated as many times as the length of the array. That's the maximum number of times you need to do it to completely sort your array. Previously, we did this 3 times and we were able to completely sort our array. So I already wrote a simple program and all it's doing is that it's making an array called A and it's initializing the values for A. This makes it easier for us to input different values for the elements of A and test out if our sorting algorithm does work pretty well. Right. So now let's actually write a program. Let's follow these 4 steps and let's see if we can sort an array using a bubble sort. So the first step is checking if our current value is greater than the next value. So we're obviously going to use an if statement for this. We'll write an if statement where we're going to check if our current value in an array is greater than the next value. Now, we saw previously that this is usually written using the iterator. Since we'll have an outer loop and an inner loop for this program, we'll use j as our iterator. So we'll check if a of j, our current value, is greater than a of j plus 1. It's the same program. The only change I made is changing the name of the iterator. Instead of writing I just wrote j. So we're checking if our current value is greater than our next value. In this case, since we're going to sort our array in an ascending order, we're going to swap the two values. To swap them, we're going to use a temp variable. So let me just make a temp variable. We'll just make a variable called temp and we'll set it to 0. And inside my if statement, let's just swap the two values. And we already learned how we're going to swap them. The first step is we're going to store this value at a of j into our temp variable. So we'll set temp to a of j. Then we're going to copy the value at a of j plus 1 into our a of j. Or we're going to copy the value in our next element into our current element. So we'll say a of j is equal to a of j plus 1. Right. Till now, it's what we've seen before and it's pretty simple. After this, we're going to copy the value in temp, that is a of j, into a of j plus 1. So we'll just say a of j plus 1 is equal to temp. And that's it. In just 3 lines of code, we've done this simple process of swapping the two elements. Now we need to get to our third step. We basically need to continue this process of checking the condition and swapping till the end of the array. So what we're going to do is we're going to make a loop that surrounds this if statement to repeat this process multiple times. So we'll make a for loop and we already know that our iterator is going to be j. We'll set j to 0 and our condition is going to be j is less than or equal to 4. But wait a second. I told you that when your iterator ends at the last index, remember 4 is the last index for my array since the length of the array is 5. If the iterator ends at the last index, it's going to cause an error, the array index out of bounds exception. Because let's say that j ends up at 4. The last value of j is 4. When you try to access a of j plus 1, which is a of 5, you notice that a of 5 does not exist in this array. So that's going to cause an error. So what we're going to do is we're going to make sure that our index is not going to end at 4, but at the element before that. So we're going to make it j is less than or equal to 3. Again, the same things we've seen before, just written using the Java programming language. And after this, we're just going to increment the value of j plus plus. Let's just copy this code and let's add it over here. Right. So we're doing this one process of swapping the consecutive elements based on this condition a particular number of times, controlled by this for loop. Now our fourth step is saying repeat 1, 2 and 3 as many times as the length of the array. We know that swapping the consecutive elements one time isn't going to completely sort our array. We need to repeat this one process multiple times. And this is where you would use an outer for loop. So now let's just make our outer loop. Our outer loop is going to be using I as our iterator. Int I is equal to 0. An important thing is that the name can be really anything. We usually use I and j so that it's universal and constant for different programs, but you could use a different name for your iterator. In this case, I'm making an iterator called I and I'm setting it to 0. Since we need to continue this as many times as the length of the array, I'll just say I is less than or equal to 4. Because you notice that this loop iterates 5 times, which is equal to the length of my array. After this, we're just going to increment I as usual. Let's just copy this piece of code and add it in our outer for loop. Right, we're done with our program. In nearly 6 lines of code, we made sure that we can sort any array in an ascending order. And the program itself is really simple. We're checking if our current element is greater than the next element. If this is true, we're going to swap the two elements. We're going to repeat this process till we reach the end of the array, and we're going to do this one process as many times as the length of our array. It's just 4 steps. Now we're just going to add this piece of code that prints all the elements of our newly sorted array. Right, so we're done with the program. We're just going to have to run our program. You notice that it asks me to enter a value. So we're going to have to enter at least 5 values. We'll enter 3, 1, 7, 25 and 8. And you notice that when I click enter, my array is sorted from the least to the highest value. So our bubble sort works perfectly well. Now we'll run this program just one more time, but we'll enter negative values and see if it still works. So let's just enter only negative values, -3, -6, -1, -8 and -9. When you click enter, we notice that I get -9, -8, -6, -3 and -1. From the least value to the largest value, we've just sorted our array. So it works perfectly well. Now, what if I want to arrange the elements in a descending order rather than an ascending order? Well, then there's only one change you're going to make. The only thing you're going to change is this condition. You're going to write it as a of j is lesser than a of j plus 1. We're going to check if our current element is lesser than our next element. And if that's the case, we're going to swap them. We'll notice that when we do that, the smaller elements moves to the end of the array. So in the end, we'll eventually sort our array in a descending order. You can manually iterate the array and see how exactly this would work. And that's it. That's all you need to know about using the bubble sort. In the next video, we're going to be learning about something called the selection sort, which is a lot more efficient and way more faster than the bubble sort. Till then, thank you for watching.